everybody. Thank you so much for joining us today. Josh and I are traveling the world. Where are we today? Are we in Studio 37 or where are we?
No, either we're on the back lot of 37 or we're somewhere hot maybe. I really not quite sure what he's got behind us, to be honest with you. I see a green screen. I don't know what he's going to put. You know, for all I know, he could have a plane coming behind us, or, you know, we have no idea what he's doing. You know, we have had the dinosaurs, so that thing might be behind us as well.
It very well could be. So, or we could be out in the desert, Saudi Arabia or somewhere like that. So,
you know, it'd be funny though, is knowing that this is a hot weather concrete. If that joker put the Himalayas behind us or something along those lines, you know. So we're here in the short sleeves and safety vests, and there'd be a cold climate behind us. That'd be kind of hilarious.
All right. So, what are we talking about today, Josh?
Concrete. Always concrete. And let's just talk about, you know, we have talked about concrete durability in the past, but today I'd like to talk to you a little bit more like, what does concrete durability mean? As far as, you know, people say, you know, they want the concrete to last longer, but how do we get it to work that way? What programs do you have in place to really look at your concrete and see what you're looking for from a design standpoint?
Sure. So we always have heard concrete talked about in terms of compressive strength, and that's very important. After all, we want the concrete to be able to hold up the loads that we design it for, right? So concrete durability has been talked about for many years, but only in about the last 20 years has it really gained some attention. And ultimately, it just refers to the concrete's ability to resist environmental effects. Can be loading as well, or can be other mechanisms, but the ability to resist those effects and last a long time. That's really what durability is all about. So there are ways that you can estimate how durable concrete is going to be. There's a lot of different exposure conditions that can cause concrete to degrade sooner than we want it to. And those exposure conditions, for the most part, are pretty well understood when we dig into things.
We're talking about environmental conditions such as, you know, heat, cold, de-icing chemicals, things like that, which we've talked about in the past, but then there's also containment concrete that, depending on what they have inside of it, is also going to be part of that environmental or exposure.
Right, so
you can look at different things as far as that's concerned.
Yeah, so things like chlorides especially. Chlorides come to mind simply because they're important to consider for concrete durability because they penetrate into the concrete and then get to the reinforcing steel, where they then reduce or breach the passive layer that's around the reinforcing steel, and that can cause the corrosion reaction to begin happening. That corrosion reaction, according to Neville's model, is self-sustaining in the presence of water and oxygen. So all it needs is just that little spark from the chlorides to get kicked off and rebar to start corroding and rusting, and that manifests itself in damage to the concrete because the reaction products of rebar, I think I read somewhere that they're around 4 times the volume of the original steel. So it expands and causes the concrete to delaminate from the rebar, or causes the concrete to crack and have other problems.
Right, which we talked about in previous videos as well. So what we kind of want to do is take this series beyond and get into what life cycle looks like. There are the programs that are available to people, and then we're going to talk about the testing involved in it. Watch out for new videos. We are going to be talking about a couple different tests, and we're going to talk about NT492, the N12390, and chloride ponding. So stay tuned.